Hello friends, welcome to the fifth session of this tutorial series. If you have not watched the previous sessions, please do go ahead and watch it. I have given the links of my previous sessions in the description section below. So let's start our fifth session. Today we are going to analyze our three-story building. Till the previous session, we have given all the loadings and all the details to our building. So to analyze our building, first let's go to analyze. Then we have to mesh our floors. For that we will go to auto mesh settings for floors. Then we will give the meshing size as 1 meter. That will be the maximum meshing size. It is given as 1 meter so that it is a unity, so that our meshing will be proper and our load distribution of the floors to the beams and to the columns will be appropriate. Then click OK. Then next we will go to analyze again. Then we have to check our model, so that we will click check model. Then we will select all. Then we will click OK. Now ETABS will check our model whether all our drawing has been proper and the joints are in proper order. So we get a warning message, model has been checked, and no warning message has been generated. That means our model is appropriate. Then we'll go to analyze. Then we'll go to run analysis. Now the ETABS will be analyzing our model. That is, it will do the automatic distribution of the loads given on the floors to the beams, then to the columns, and it will generate the bending moment diagram, the axial load diagram, the shear stress diagram of the beams, columns, and the slabs. Now after analyzing, we will get a image on the 3D view, because while analyzing we have selected our 3D view display. So the analyzing result will be shown in the 3D view display box. So here we can see after analyzing we got a deformed shape. This is actually the deflected shape of the building when only dead load has been assigned. We can just see the deflected shapes, and if we go and put our cursor at a point, it will show the different values, that is displacement in the x direction, y direction, z direction, and the rotation that took place in the x, y, and z direction. These values will be in mm. As you can see here, the dead load displacement, it is given in mm. So if you go to here, we will be seeing that joint label is 19, the story is 3, and the displacement in the x direction was 0.101 mm. Then we'll just go and click show undeformed shape. So it will give us an undeformed shape. Now to get the bending out of our beams, we'll go to this, that is display frame pier link forces. On clicking this, we can select our load combination. Just go to and click combo. Then in this drop down panel, we can get all the load combinations that we have assigned. So let's select a dead load plus live load combination and we'll see the results. We'll take the bending moment in the direction moment 3, 3. That is the major axis bending moment. So we'll click OK. So here we can see the bending moment diagram. Just we'll click on this beam, then we'll right click our mouse button, then it will show that beam particularly itself. In this we can see that the first column is the shear force diagram. We can see the maximum shear force here, that is minus 28.5 kilonewton, and it is at a distance of 3.7 meter from the beginning. And this is the bending moment diagram. We can see it's a quite really good bending moment diagram we have obtained, because at the supports we have 90 moment, and at the midpoint we have the positive bending moment, that is sagging. So while viewing this bending moment diagram itself, we can see that the loading we have given and the analysis done by the ETABS is correct. And the shear force diagram itself, we can see that it is going as per we could have visualized, because at the junctions the shear force diagram is varying from negative to positive, and this is the deflection diagram. Now to get the value of the bending or shear force or deflection at any point, we can just left click our mouse button here and just drag this green bar so that we can get the value at any point we require. Now if you want any other load combination, we'll just go and click this tab and we can select any other. That is, we will select 1.5 dead load itself. So we get another bending moment diagram, shear force diagram, the deflection diagram. Now to recognize this beam, ETABS has already given a name to this beam, that is B5, and the story is plinth. So like this, ETABS has already given the naming to all the members, that is all the beams, columns and the slabs also, so that while taking down the bending moment and shear force diagram, it will be easier for us to identify any particular member. Now we will just click done. Now if you want the bending moment diagram of any column, we will just select the column and click right mouse button, and here we get the shear force and the bending moment diagram. Then we will just check this component and we will select axial, that is axial force. See, the axial force on the column is maximum is -348, which is at the bottom. See, while moving this cursor, we can see its representation in the 3D view with the help of a red spot. See, while we are moving our cursor here, the red spot in the 3D view diagram is also moving. So we can exactly visualize where we are pointing at. Then we can click OK. Now we had an overview of how to get the bending moment diagram and the axial force diagram of the beam and the column respectively. Now we will just check out the bending moment diagram of the slab. Now to get the bending moment diagram of the slab, we will go to plan view, because in this we can visualize our slab in a more clear way. Then we will go to this display shear stresses and forces icon, then left click our mouse button. Then we'll click this M max, that is, it will show the maximum bending moment diagram of our slabs. Then we'll select the load combination as combo. Then we'll go to and select 1.2 dead load plus 1.6 live load. Then we'll click OK. So here we can get the bending moment diagram of our slab. If we go and select if we go and click on this any small portion, then right click, we can see that particular portion highlighted, that is a blinking yellow border will be showing, and we can, with the help of our mouse cursor, we can get the bending moment value at any point we require. Usually while designing the slab, we'll be selecting a bending moment value of the slab which is not quite close to the support. In this case, we can see that this dark yellow portion is over the column beam support. So we'll just go back and probably select a value like 0.78 -0.785 for a design purpose, which we will be discussing later in our next tutorial. So we'll just go ahead and close it. So like this, we can select any bending moment value of a slab by just right clicking and just moving our cursor around. Now we'll again close it. Now next, another thing we require is the reaction of the supports, because we need to design our footing also. So to get the reaction of the supports, we will go to our 3D view again. Then we'll select this display support by spring reaction. Then the plot type will be arrow, so that we can get a visualization how the reaction is coming from the ground. So combination will select as combo, dead load plus live load itself. Then what are the reactions needed to be displayed? So we'll select all, that is reaction in the Z direction, that is the upward, which will be the main component. Then in the Y direction, X direction, then the moment also in X and Y and Z direction. Then click OK. So let's zoom in and we can see that the reaction in the upward direction, that is the main component, is 267.33 kilonewton, value will be in kilonewton. And here we can see that there is no moment displayed. It is because while drawing our building, the end conditions at the base, that is the support, we have given it as hinged. As you all know that at the hinge there will not be any moment generated, that is moment restraining will not be there. So here we get only the reactions in the horizontal vertical directions, and with the help of this we can get the maximum value. How to get the maximum value of the reactions and the beams and the column and also the slab, and how to go ahead with the design, we will be discussing in our next tutorial. Our next tutorial will be focusing on the design of only footing. So if you like this video, just give a thumbs up and don't forget to subscribe and leave your valuable comments in the comment section below. Thank you and see you soon.